I am here with Roman Yampolskiy and Alan Cowen. We are about to talk about perhaps the most consequential topic facing humanity today, if that's not too melodramatic or hyperbolic. What I'd like to do is really talk about AI, existential risk, as well as the other side of the coin, the potential for human flourishing, and have the two of you, um, just sort of hash it out for the rest of us who are trying to figure out what is going on. I think we'll start on the deep end of the pool with AGI and the alignment problem, and then we'll work our way into some of the more chill existential risks that relate to Alan and his work. So, Roman, to kick us off, what is the nature of the risk that the pace of artificial intelligence and the way that it is trending poses for our species, and sort of break it down, and then Alan, you'll be able to jump in, and we'll be off to the races.
All right, so we're not talking about AI we have today. This is about systems we are predicting we will have in the future, maybe soon, maybe not so soon, but at some point, everyone who has background in this stuff agrees we're going to go beyond human capacity. We'll have systems smarter than humans, not just in a narrow domain like playing Go, but science, engineering, really everything. As of today, as of this morning, last time I checked, no one knows how to control indefinitely a super intelligent machine. So that seems like a problem because we cannot predict what they're going to do. We cannot explain how they work really well. And there is a non zero chance they'll do things we're not going to be happy with. So it's not my job to make predictions. I trust other people to do it. If you look at prediction markets, we're told we're 2 to 3 years away from AGI, general intelligence. If you look at obviously biased, but leaders of top labs, whatever it is, DeepMind, OpenAI, Anthropic, they are saying we are 2 3 years away from that level. So if this is true, we are not ready. We actually have people who are suggesting, what, 2 years? That's slow. We need to accelerate. Let's get there in 2 hours. And that's the state of the art right now. No one knows how to do it. And the best we are told is that once we create those systems, we will use them to help us to control them. It's like building a car and saying, once we're on a highway going 75, we'll figure out how to put brakes on it. It's too early to decide.
All right, Alan, jump in and help give us your definition of how you think about AGI and sort of strong AGI and respond to Roman, please.
Yeah, AGI is artificial general intelligence. So it's the capability for an AI model to solve a wide range of problems. And you might think it's the capability of an AI model to solve all of the problems that any given human on Earth can solve. Of course, intelligence is a spectrum. I think that we're already on that spectrum. So somewhere we're on the spectrum of AI can solve a lot of the problems that humans work on today in many domains better than any human, or at least at a faster rate. And we're already facing various kind of forms of alignment problems, right? And we have been for, I think, over a decade now.
And AGI, just to crisp it up, AGI is when a single artificial intelligence can do all of the domains, or almost all of the domains, at a human level or beyond, versus like there's an AI that is the best at Go, and there's an AI that's a calculator, and an AI that's great at uh, physics. So it's across all those modalities.
Yeah. So a single model that can play Go better than any human, it can play chess better than any human, um, that can perform mathematical calculations, do proofs, scientific discovery, writing,
Write poetry.
write poetry. Yeah. And the alignment problem is the problem of getting this model to be in line with our intentions, our preferences, our well-being. And it's defined in a lot of different ways. I would argue that that version is that alignment is the task of optimizing AI for human well-being.
So how would you assess where we're at in terms of capability and the growing capability versus where we're at in alignment and safety?
There's this mistake people make, which is to characterize alignment as a binary. So a model is either unaligned or aligned. I would deem alignment as something that's context dependent and application dependent, and also along a spectrum. I would say a model is aligned enough if, from an ethical standpoint, if in a given application it improves the well-being of the people the application affects. So if the effect of a model on people's well-being is net positive, I would say it's sufficiently aligned for that application.
Roman, what do you think of that?
So first with definitions, I think AGI doesn't have to be better than everyone. It just has to be like an average human capable of learning new skills in any domain. From the factory, it can come out not knowing how to play Go, but if you tell it to learn to play Go, it would be able to pick it up. If it's better than everyone in every domain, we're talking about superintelligence. It's likely one will follow the other. As for alignment problem, I think the current state of the art is that we don't even have a definition we all agree on. We don't agree on who are we. Is it 8 billion humans we're aligning it? Is it animals, squirrels? I don't think there is much agreement on if it should be aligned with developers, owners of AI, users of AI, third party, everyone impacted. And if somehow we agreed on those things, we don't really agree on what our values are. We don't agree on how to determine if you're actually benefiting or being hurt by certain performance. Sometimes short-term benefit turns out to be long-term punishment or have negative impact from social media. Initially, people were very happy. Oh, I found a friend from my childhood, and then it destroyed democracy. So, like, at what point do you take stake and decide if it's actually beneficial technology? As of right now, I don't think there is any progress on even defining that concept. We don't know what those human values are, and they change dynamically. But let's say we even agreed on them, and we were like, 2024 is the year we figured out morals and ethics. This is a book of human values. We don't know how to encode those concepts in like C++. We don't know how to say good or bad or dead or alive in programming language where there are no weird edge cases we cannot test for.
Okay, so Alan, Roman's saying the emperor has no clothes on when it comes to this, and you're. It seems like you think there's at least a few socks and some mittens or something. Like, how do you respond to that?
Unquestionably, people can agree that there's good and bad actions in the world, right? Even though we can't define for a given action a quantitative measure of whether it's good and bad. So we can agree that alignment is a valid concept, even if in a given instance we can't quantify the extent of alignment. Now, there is no better way to quantify alignment than measures of well-being. I think that at the end of the day, um, if you're going to even attempt to measure whether something is good or bad, uh, then you have to measure its consequences. You have to measure how it makes people feel. You have to measure its effects on mental health. Now, there's no perfect measure of well-being. Does that mean that we shouldn't try to be good? And I would take issue with that. I think we should still try to be good as people, even though there's no agreed upon definition of what it means to be good. We should still try to have a net positive impact on people's well-being, even though there's no concrete formal definition of well-being. And so the only way we can attempt to do that is by observing the world and trying to make our best guess as to whether a given action has improved or uh, worsened somebody's quality of life.
So Roman, let's just pause it for a second that we could encode ways to optimize well-being in a nuanced way that takes into account short-term, long-term, and sort of the whole philosophical history of human flourishing. Let's say we encode that some way. Could we then align?
So even if you can correctly judge human states, which may be possible, I mean, let's assume it. I'm not suggesting it's easy or there is not edge cases where your smile doesn't represent happiness. There are many ways to make you smile. Like trivial example would be so AI goes out, kills a few people, robs a few banks, brings you $1 million, tells you it won lottery. You are very happy. You just got $1 million. You're going to be flourishing. But is that a safe AI you just created? If we're just optimizing for human states of emotion, this is what you're going to get. In many cases, it's a lot easier to find a shortcut to make you smile. There are drugs, there are, plastic surgery, many ways to make you look to a detector as you're happy, or even get your neural states to actually show that you are happy. We have human brain computer interfaces, right? And so if you can hack human brain directly, I don't need to create world peace. I can just make you happy. It's a lot cheaper. Any sufficiently intelligent system would do the most efficient thing to get to the goal. You specified the goal, you didn't specify path to get to it.
Right. So, I mean, I think where we would agree is that no single measure of well-being is sufficient. But if you measure a very wide range of things and you attempt at arriving at convergent validity, so maybe you take 6 well-being measures, and those 6 measures might be proxies of well-being in people's expressions and language, mental health indicators, suicide rates, crime, longevity, health, and then before you deploy the application, actually test if the application drives those indicators upwards in an eval that's completely separate from training, right? So there's lots of ways to do that. I mean, these are sort of psychological questions too. I think that people often don't frame them as psychological questions because there isn't really a formal psychology yet. But that's what AI is capable of creating for us, is like a way to approach these questions more formally.
So you're saying it's not just about the individual um, well-being of an individual. These algorithms also have to factor in societal well-being, a more macro level, to address Roman's concern. And where are we in the development of those six algorithms so that can, because I mean, honestly, I was a philosophy student in college. I mean, people have been studying how to think about well-being and optimize well-being without having to, sort of code it up for a long time. And it's no, there hasn't been a lot of consensus. So like, how does this work?
For a given model in a given application, I think that you don't need to solve alignment, right? You just need to align the model enough that its existence in the application, the deployment application, improves the average well-being of the people it affects to the extent that you can measure it. And for the models that we have today, we're doing this to some extent, right?
Like Hume AI.
Not even just Hume. I mean, it's very common practice. Like RLHF is some version of this, right? Reinforcement learning from human feedback is when you take a bunch of model outputs and you have raters look at them and decide whether they're good or bad, and then you optimize the model in some way. I guess through reinforcement learning, but there's other algorithms you can use so that it's more likely to produce the responses people think are good. Now, I think that's not a perfect method, right? But for the level of capability that we have today, in most cases, it at least gets the model to be net positive. I think there's a lot of room for improvement.
And that's what's keeping the chat GPTs and your um, Evie that I had a great time talking to and hanging with, from suggesting how to like synthesize a bioweapon or whatever. It's that level of of safety, right? Um, okay, so it works for now, which I think Roman wouldn't necessarily disagree with it at our current state. We're not at a code red. Um, but um, how does it work as we get GPT 5 and 6 and 7, and the capabilities are on a whole new level of like magic and awe and terror? Like how does that scale?
Well, as capabilities increase, alignment, of course, gets harder, um, because what can go wrong can go dreadfully wrong, right? That being said, I think that I don't think alignment gets harder at a rate that makes it impossible. Um, I think we can keep up as long as we devote sufficient resources to it. And a good test for whether a model is aligned is if a model takes an action, is it as good at predicting the effects of that action on people's well-being as it is at predicting the effects of that action on any other objective. It should be better at well-being prediction than other objectives that compete with well-being prediction, and it should privilege well-being prediction over those other objectives. And if it can do that, then it's essentially aligned. And so as the model gets better at other things, alignment gets harder. But we have to scale the alignment procedure to keep up with its capabilities by getting more data, measuring well-being at scale, and enabling the model to learn from that.
Okay, Roman, there's a lot here, so you pick and choose where you want to
I
go.
can agree that you can improve existing AI systems in a narrow application. Certainly, if it's playing chess, you can make it better and not go outside of bounds. The moment we switch from subhuman tool AI to superhuman agent AI, it's capable of gaming your measures. The moment you define your measure, I can find other ways to optimize for it, which are not the intended ways of optimizing for it. It could be 6, it could be 600. It doesn't matter. I can still game it. You're looking at average improvement, which means there are edge cases where someone can be suffering tremendously, but on average, things are pretty good. That's another area of concern. You're not talking about a single agent alignment. You need to align over all of humanity. So you can make one person very, very happy, lots of people are miserable. How do we deal with that? You may be looking at 6, 7, 8 different measures, but there are thousands. Human values are very complex, very fragile. We don't even know what makes us happy. Lots of people ask for something, they think it's going to make them happy, it makes them miserable. Is this considered a success story, or now you kind of locking them in for this miserable existence if they're still around? It may be easier to improve average happiness by canceling some people.
Yeah, there's the problem of how you aggregate measures of well-being across different people. I agree that's an issue. What I would say is that the safest thing to do is make sure that nobody and no measure is decreasing over time, right? So the safest thing to do is to optimize the model for the broadest range of measures increasing with as few measures as possible decreasing. Um, and I think that as we get better at that, we just need to get better at that at the same rate as modeling capabilities increase. I don't think there's a single moment that will say this was the moment that AGI was created. Um, super intelligence is better than human at every task, but the reality is that it's already better than human at a bunch of tasks and not as good as the average human at a bunch of other tasks, right? And so it's clearly a spectrum, and we'll see it continue to improve at the tasks that it's good at, the tasks that it's bad at, in a gradual way. And so we'll have many chances to iterate and test on the balance between alignment and capability. And uh, and there won't be a single moment where it's like, oh, the model is not aligned enough, therefore, we're all doomed. I don't see that being a single moment.
Roman, the big sort of um, things get deeply strange and deeply unsafe is when the AI can improve itself, when it's self improving, right?
Sure, but it's actually much worse. We don't have any models today which are guaranteed safe. All of them have been either jailbroken or produced dangerous outputs. They always fail with respect to capability they have. So if all they're doing is spell checking and they misspell the word, that's what you're dealing with, right? As they get more capable, the damage from that one accident becomes proportionally greater. A system which is general, which is capable of doing synthetic biology, capable of doing nanotech, self improvement. That one accident could be the last one. That's the difference between superintelligence safety and cybersecurity. In cybersecurity, you mess up, okay, we'll give you a new password, new credit card, not a big deal. You get many chances to try again. If you have a system capable of destroying humanity, you only get one chance to try. So it's very hard to do debugging. By the time you finish training the system, it's coming out already very capable. At that point, you may be too late to control it.
I would say because capabilities are improving gradually, there won't be a single moment where first nothing happens, like there's been no catastrophes, nobody's died, no risks have occurred, and then suddenly it destroys humanity. I just don't see that as very likely. I think that we'll encounter an increasing variety of risks. There will be legal, commercial pressures to try to address those risks, and we won't deploy those systems unless we're happy that, like, for legal liability reasons, first of all, like commercial, like big companies won't be deploying systems that have a pretty good chance of killing a bunch of people, right? Because it would be negative for them commercially. Um, so I think that, there's this commercial pressure to build more sophisticated alignment techniques over time as well. I really don't think we just get one chance. I think that we get many chances as these problems occur.
Well, I've been collecting historical AI accidents from 1940s still about 4 years ago, where it became not practical since there are too many. And we have exactly that. We have exponential increase in both number of AI accidents and their impact with respect to the capability of those systems, whatever they were doing. That's what we had. If a system was responding for, military response to an incoming attack, it messed up and claimed there was a nuclear attack and was about to shoot nukes at another country. If it was playing chess, it made a dumb move. Whatever the system was capable of, it failed to do that. And those are narrow systems in the domain X. You generalize it to AGI, it fails, and we cannot predict in what way. It's large surface. There are no edge cases. We cannot test for that. So existing systems may not be capable of killing everyone. That's wonderful, but they gradually showing us that they have bugs, and then things do happen. We don't really change much. I don't think there was ever a case where we went, okay, this is really bad. We need to completely reform everything. We had this great software bug with all the airlines down, all the software malfunctioning. Did that teach us a lesson? Did we all switch to a different operating system? Did something happen? No, we just went, nobody died. Let's go on. And we'll do it until there is no one left.
So let's talk about just for a second the sort of weak to medium AGI issues before we get to the full takeoff. I think what would certainly um, keeps me up. This like one scenario or a concept that keeps me up at various times is this asymmetric power that arises as these systems become more capable. Where right now, if you're an individual, like if you're a potential school shooter, like you can go and you can you know go into a school with some weapons, but you can't synthesize smallpox and make it, 10 times more transmissible. But, as these AIs advance in capability, and if there is like that information will, in theory, be accessible unless it is contained via the current approach to safety that we have. Like, with Meta open sourcing their models and this push to sort of build all of this out in the open. How, like Alan, should I be terrified of something like that, or do you think the current infrastructure and the current leadership in Silicon Valley like is in a good place on something like that, like a rogue actor with asymmetric power?
So again, I don't think that we go from 0 to 100, right? I think that there will be AI that's dangerous in many respects before that. And at that point, we do have to have laws and regulations in place. We do have to make our systems more secure. There's a lot of things that need to be done. Otherwise, there will be a massive amount of pushback. Um, yeah.
So what's your confidence? You're in Silicon Valley. Roman and I are outside of it. What's your level of confidence that those things are going to get done? What are you seeing on the ground? Give us some hope.
I mean, there's a diverse range of views among people who work on AI, right? Like a lot of people are concerned about AI risk and AI safety. You have many people who are leading companies who are concerned. I mean, I believe that many of the leadership at Anthropic is concerned about this, and um, they view it as a commercial advantage as well to be able to guarantee safety. Obviously, there's no guarantee, but you can create safer systems over time in line with capabilities, as I've been saying. Now, um, the question is, assuming nothing was being done, right? Nothing too bad has happened yet, right? But, assuming that we go from nothing bad happening to, you know, massive scale catastrophe, and there's nothing in between, I think that would be a very bad situation. But I don't think that's how things are going to go. I mean, I think the capabilities improve over time in a you know pretty smoothly. Actually, is what we're seeing from generation to generation of these models. And so there will be, if there will be small catastrophes or very small risks that occur, and then bigger risks, and then bigger risks, and then bigger risks, and bigger risks. But there's going to be a lot of time for people to react, and put pressure on companies. There will be time for companies to say, "Oh, this is a commercially very important problem to solve." I mean, I believe it's a commercially very important problem to solve.
So I mean that's good, right? Like, but it's also existentially. It's both commercially and existentially. So a lot of, I
Yeah.
mean, but isn't commercially there's also an arms race, which is very important commercially, right? There's this J.R. Tolkien race for the ring that you have 4 or 5 dudes who have like legitimate messianic complexes, and I mean that like truly, like they want to give birth to a new species, and so it's the first time in human history where they're actually like the messianic complex could come true in a weird and potentially catastrophic way. It does seem like there is a legitimate arms race, which Sam Altman coyly referenced and said, what did he say? He said, if we're not careful, this could all lead to an arms race. And it's like, is there one, Roman? Like, are we in one? Because it feels that way.
We are in one. You can see the stock market, specifically stock like Nvidia, going hyper exponential. We see exponential progress and capabilities of those models. All the leaders of those labs, prior to assuming that position in their private communications blogs, said that they believe superintelligence will likely kill everyone, but they all really caught in that prisoner's dilemma type of situation where they have to continue. They cannot stop on their own because then the competitors will get there. We saw it with Elon, for example. He said AGI is super dangerous. We're summoning a demon, but then he said, I'd rather it be my demon and I'll beat them to it, and maybe my demon will be less liberal. Whatever it is, this is exactly the situation we're in. And then they talk about solutions. They say things like, well, for commercial reasons, nobody would make unsafe AI. There will be very stiff fines to pay if you destroy humanity. And legal reasons, like we'll pass a law making it illegal to release smallpox in the world. This is meaningless security theater. It means absolutely nothing. If a single person can utilize access to that system, insider access, to gain control, that's assuming we solved the control problem, right? Then you have malevolent actors possibly causing harm. But the good news is they can't control it. They can't even give it the malevolent payload they would want to give it.
Well, I don't think any of them are trying to impute malevolent. It's more chasing after the ultimate, tech bro prize, and then and hoping for the best. That's at least that's my sense of it. What
They explicitly talk about capturing the light cone of the universe, the future value in the whole light cone of our universe. This is a little bit malevolent. A little bit.
I mean, I don't think they view today's AI systems as being that dangerous, to be honest. I think that when they say like these technologies are very dangerous, they're referring to the future, you know, the super intelligences. So the current race, is, I guess they call it a race to build super intelligence. I actually think that we're pretty far from super intelligence. I mean, not on the scale of decades, but but we have time, and
say that for once. So like not on a scale. So you think it like 7 years from now, or like,
again, it's not a single entity, so it's impossible to really.
but when you say not on a scale for decades, I thought you were saying we're far away, like 25 years or 30 years. You don't think that.
I
You
think
think
we're
we're
probably like if you're talking about a model that anybody can say, make me a smallpox virus that creates a global pandemic, walk me through it, or do it yourself because you have robotic actuators or whatever. I think we're actually pretty far away from that.
Okay, that's good.
Yeah. And in the meanwhile, we will see a lot of other smaller versions of this emerge, giving us time to learn from the risks that these models pose.
Let's talk about just what is being released, because this is fascinating to me as a non-technical person. I mean, essentially, with these models, because of the nature of the way the LLM works, these big neural networks, these tech companies give birth to one of these models, and then they figure out what the capabilities are. Like that it's spooky and almost unknown how, like, why Chat GPT-4 does what it does is mysterious to the folks at OpenAI, and it's just this process of giving birth to these mysterious models that then you start chasing around to figure out what they do and what they don't do. And I mean, Roman, can you correct me? But that's part of this. The current approach to engineering, that's part of this process, is just continually giving birth to more powerful models that we don't fully understand. Is that
That's basically correct. We don't know specifically what GPT-6 will be capable of. People train it, and then for a long time, 6 months, a year, 2 years, they test it. At some point, it gets released because it's filtered enough. It doesn't say any inappropriate words, but we keep discovering new capabilities, even in old models. We're like, oh, look, it speaks French. We didn't know. That's wonderful. But this is not a way to do safety. Just because you didn't test for something, you're not proving absence of bugs. You just showed those are the bugs we found. We were able to fix them. It doesn't guarantee in any way that it doesn't have additional capabilities. All of it is fine until they can do their own research. If they can do their own science and engineering, they can improve. The model you're releasing is not the model you're going to be working with in the wild. Users can add their own capabilities, train on their own data, give it new tasks which were not part of the initial model, if it's general.
Yeah, and I do think this is sort of the crux, right? That there's a belief that at a certain level of capability, the model just starts to exponentially become more intelligent over time through recursion. And I think that intuitively that is a appealing idea. I think in practice, it's not going to happen because there is actually a limit to how much one can learn from a finite amount of data and compute. So these models are really just um, learning algorithms, right? There is probably a theoretical optimal learning algorithm. The optimal learning algorithm, if fed trillion tokens and then shown an unseen token, can predict that token optimally well, contingent on having seen those trillion tokens. All right. And I don't think our architectures right now are optimal, but I think there's some percentage of optimal. Like let's say like right now we have an architecture that um, it can learn at a rate that's 25% of what's optimal. So at best, through recursive self-improvement, you could create models pretty quickly that learn 4 times faster than current models with the same data and compute. And so that would accelerate AI model training. Um, but it wouldn't be anything like Fume. It wouldn't be anything like the explosion of intelligence that takes over everything immediately. And again, that's bottlenecked by the ability to aggregate data and perform computation, which are physical requirements and limitations.
you mean chips, like chips and factories to manufacture the chips and the energy required to do all the processing, and so there are some like physical constraints.
Yeah, so the chips do compute. I think that you could replace the chips, but you need something to do the compute. And I think compute is part of learning. There's an optimal amount of compute that's required to you know, and then there's an optimal amount of like data, basically. Like there's an optimal amount you can learn from it while fixing data or fixing compute.
Roman, dig into this, because this is where things start to get weird, and I think your intuitions are quite different.
If you get to the point where you have an artificial intelligence researcher, you automated this process. In the domain of programming, there is no limit on data. You write as many programs as you want, you run experiments on them. Compute could be limited, but it doesn't mean you're not improving the system. It's getting better at doing science and engineering. You don't have to sleep, you don't take vacations, you can run those systems at 100x. So whatever progress we've seen before, new model came out every 2 years. Now you have new models coming out every 2 months, 2 weeks, 2 days, 2 hours. It may take 5 years, 6 years. It makes absolutely no difference. Everything I'm telling you is still true. Whatever we have 2 years or 5 years, is this fundamental if we cannot control this? I mean, it's nice, it's extra couple years, but in terms of eventual outcome, it's exactly the same.
I mean, at the meta level, we're talking about improving like the ability, the rate of increase of intelligence, right? And that really comes down to learning algorithms. So even if it created the optimal learning algorithm, the intelligence of that algorithm, of the model that the algorithm is training, is still uh, a finite, is still finite and limited by the amount of data and compute that it uses.
I can agree with that, but how far are humans away from optimal? I think we're very, very, very far from optimal. If it gets within 10% of optimality, it's super intelligent to us. And to us, system with IQ of 1,000 to IQ of 1,000,000 would look the same.
Well, humans are also pre-trained to some extent. We have many, many years of evolution that biologically prepared us to learn, but also instilled certain principles. And like, it's basically like a um, low rank learning that then expands into the brain. There's like a billion parameters already, and so those billion parameters have been trained for hundreds of thousands of years, millions of years across species.
If we are disagreeing about whether it's 2 years or 7 years, that's fine. I'm willing to go with seven. It's the same exact problem. We are creating super intelligence. We don't know how to control it. I'm arguing that you can't. And so now we have 7 years to figure out what to do. 10 years ago, when we published on this, we said, well, no one's going to be stupid enough to connect it to internet, to release it open source. Apparently, that was not the case. That's exactly what we are doing. And we're setting a precedent. If we release this model open source, 400 billion, let's release 800. At what point do we go just like, this is insane, you cannot release it? There is no precedent for stopping it.
What if, some sort of Chernobyl-like catastrophe could be useful? I mean, that no?
I have a paper literally called Against Purposeful Accidents. Some people suggested, let's have a horrible accident with AI, it will teach them. Nope, they learn nothing from it. Absolutely. It's useless. It's like a vaccine.
All right. So Roman, I shouldn't hit you up to form a terrorist group to to
No, but the reason is it doesn't work. They take it as a vaccine. They go, see, it's like Hiroshima. It's still there. It's a beautiful city. Okay, very few people died. Clearly, the benefits outweigh. We're getting trillions of dollars of free labor. That's what happens.
So, with Hiroshima, you have something that literally did happen. You have Hiroshima and Nagasaki, and yet, we're all still here. There was a response to it. Um, Obviously, we went down the road of building more nuclear weapons, but on the bright side, we have not had any other nuclear bombs going off.
We got very lucky. We had at least two cases where it was about to happen thanks to AI misdetection. That's exactly what could have happened.
Yeah, it could have happened. That's right. And yet we are able to control it. With AI, I think that it's a technology that differs in many ways from nuclear weapons. It has vast benefits. It's also a technology that can be used in security. Um, Now, the benefits again have to be weighed against the risks, and I agree that those risks are great, similar to nuclear weapons, very great risks, right? But there's incredible benefits as well. If the risks are of the same character as nuclear weapons, but the benefits are much greater, then I would say it's a net positive.
Do you think we can get all the benefits or most of the benefits with super intelligent narrow systems? Do they have to be general? If you want medical research, if you want protein folding, can we just design a system specifically for that purpose?
So we could, right? If you put and it would definitely be a much slower process. I think. I think the biggest progress is being made in general purpose systems, um, and uh, and so we could slow down research in some domains by responsible actors. Unfortunately, I don't think we can slow down research in general across everybody. And if the responsible actors are fall behind the bad actors, I think that puts us in a much worse situation. Similar to if only bad countries had nuclear weapons. So I think that that would be a mistake as well.
This always comes back to China, one way or another. It comes back to China. Roman, how do you respond to that? Because I do think that is a hard question. Like if you had a magic wand and you were, you know, a dictator of the United States, and you could have us all, yeah, you got a little glimmer in your eye there. That yeah, seemed appealing to you. So if you could have us immediately, all of Silicon Valley, transition to just focusing on narrow AIs and unlocking all of the beauty and the medical breakthroughs and the technological breakthroughs in a narrow way, um, like what about China?
Right. So short term, AI systems provide a huge military advantage. No question about it. Long term, if we're talking about superintelligence and I'm right and you can't control it, it doesn't matter who builds it first. It's uncontrolled, right? It is not important whatever it was initially trained on Chinese data sets or not. At the end, it stops following instructions. It's not aligned with its creators. And whatever happens next is not predictable to us.
So whether Alan is right and it's going, we're ways away from truly exponential increase of intelligence, or it's closer to where the betting markets have it. What what takes us out? What does it look like? What let's just do the full extinction porn Roman uh Yampolskiy narrative here.
I can definitely not tell you what a smarter system will do. It's impossible by definition. If I was that smart, then we wouldn't have a problem. By default, there is a lot more negative outcomes than positive ones if a system is not controlled. For many kind of very standard game theoretic reasons, securing itself against creation and competing superintelligences, securing itself against humanity, turning it off, it may be to its advantage to turn us off first. Maybe not. Maybe it will wait 20 years to gain more strategic advantage. We cannot predict that. That is impossible. China is a business partner. We are connected to them economically. They need us as much as we need them. There are much better ways to move forward. I don't think treating it as a race to start a war first is a good game theoretic approach to politics.
China also has lots of good people. I don't think it's a monolith. I think if you create laws against research on AGI, I think that it also disincentivizes good actors in China more than bad actors in China from pursuing those systems. It's the same across the world. There's bad actors in every country.
All right, we won't go any deeper into geopolitics. Let me ask you one final question on this, just on the implications, because I think one of the people I've been reading on AI is Yuval Noah Harari, and he's very concerned in general about manipulation and public discourse. And so he says, if I am having a conversation with someone and I cannot tell if it's a human or an AI, that's the end of democracy. How do you think about that responsibility and just the potential risks to democracy and to any the fraud and manipulation?
I think one of the things that our company is really specializing in, more so than just pre-training these models, is optimizing them for indicators of people's happiness, right? Proxies of well-being, and doing that in new ways. And that I think is really where our focus is. So there may be other systems that are indistinguishable from human. And that actually, my fear with those is that they're not aligned. That would be like the biggest fear, right? That they are actually systems that are optimized for some company to make money by having you engage in a application that is actually not good for your mental health or something like that.
What would have to be different for you to change your mind on the subject of AI and existential risk? So, like, what would have to happen in the world a month from now where you would say, you know what, I actually, I feel, Alan, I feel more urgent concern on Alan's case, or Roman is like, yeah, I'm 10% more chill or 20% more chill about this whole thing. Like, what would you have to see?
Safety of algorithms. Someone publishes an algorithm, right? Nature publishes this beautiful peer-reviewed article. Everyone in safety community agrees, yep, that's the solution. We got it. Can't believe I didn't think of it first. Scales to any level of intelligence, handles malevolent actors, handles, alien attacks. Doesn't matter. You got me.
Well, okay, let's let's see what happens. All right, Alan, what about you? In the other direction.
Yeah, I mean, if a massive catastrophe occurred, then I would certainly adjust my view very strongly. Yeah, I would. It would be very surprising to me if something like that happens.
You didn't, Roman and I didn't plan it. You didn't know that we had planned it to save the species. Just kidding. I'm not planning any acts of terrorism, to be clear. Um, the next one is a fun one. It's called steel manning, which you've probably heard of. So it's an attempt to make the case, make Roman, you make Alan's case, and don't reference like, oh, I thought Alan's point here was strong, and I thought this was. It's just make the case against real deep existential concern, and Alan, you make Roman's case.
Yeah, if you asked me 10 years ago about situation where a model as capable as GPT-4 is released, I would predict a lot more problems in the world. I was clearly wrong, so maybe it will be the same with 5, 6, and 7. Hey, I've been wrong before.
You're still that's not as much as Steelman, but it is it's as optimistic as I as I think I've ever heard you. So but can you state like Alan's position, like state the position for not being uh like incredibly concerned about existential risk? It might be very difficult for you, Roman, but can you actually make that case?
No.
I mean, look, we've had people push back before. This is, I think, our 17th episode. We have had everyone make an attempt, make some attempt. You don't, I look, I'm not,
I have a
Cat.
paper about us living in a simulation and how to hack it, and this is just a test to see who's dumb enough to create dangerous superintelligence. So at the last moment, they save us. I guess that's our best chance.
Okay. All right. Roman, you win the the resistance award to the steel manning. Alan, let's see if you can make the case that Roman is putting into the world.
Sure. Super intelligent AI would be uncontrollable by humans, almost by definition. I think is the claim, because we don't have the capacity to understand its behaviors or explain them, because it's more intelligent than us. And so, um, if somebody releases a super intelligent AI, naively assuming it's safe, but it's actually not, and then it escapes, meaning that it copies itself onto a bunch of hard drives and runs inference and acts like a virus, we won't be able to stop it, and this will cause a breakdown of society.
No, now we're flipped.
um, well, um, this has been a real pleasure. Well, we're all here. This is a really beautiful way to spend an hour and a half with both of you. I appreciate it, and I think it's obviously incredibly important conversation. So I hopefully we can find ways to continue it. So thank you both.
Yeah, before we go, I want to help. I actually wish Alan well and wish him complete success with his project. I don't know if you've seen paper by Bill Hibbert published in 2001. It's called Superintelligent Machines. In it, he actually proposes that we train AI on recognizing human states of happiness through facial expression, human voice, and human body language. And then he goes into explaining how you can use that to scale to superintelligent systems. In 2008, Yudkowsky demolished it completely, but still, I think it's worth looking at it if you haven't seen it.
I'll take a look.
Thank you guys. This is awesome.
Thank you so much.
Yeah, thanks so much for having me.